Hello everyone, and welcome back to our Data Science Bootcamp. In the previous lessons, you've learned Python basics, how to work with data using pandas, and how to clean messy datasets. Now it's time for one of the most exciting stages of data science, understanding what your data is trying to tell you. Because data science isn't just about writing code, it's about finding patterns, understanding trends, and making better decisions using data. Let's understand this with a simple business example. Imagine Matthew owns a business in Dubai. He shares customer purchase amounts with you: 1,500, 700, 2,200, 900, and 3,000. Looking at these numbers alone doesn't tell us much, but Matthew wants answers like, which customer spends the most? Who are the premium customers? What's the average spending? Are most customers spending a lot or only a little? This is where data analysis and data visualization come in. Data analysis means examining data to discover useful information and answer important questions. Data visualization means presenting data through charts and graphs so it's easier to understand. Instead of reading long tables of numbers, charts help us identify trends in just a few seconds. That's why almost every company today uses dashboards filled with graphs and visual reports. Let's start by importing the libraries we'll use. We'll import pandas for working with datasets, matplotlib for creating charts, and Seaborn for building cleaner and more professional-looking visualizations. You'll notice that we use short names like PD, PLT, and SNS. These aliases make our code easier to write and read. Next, we'll create a simple dataset. Our dataset contains 3 columns: name, city, and amount. Each row represents one customer and their purchase amount. Once we convert this data into a pandas data frame and print it, we get a neatly organized table, just like an Excel spreadsheet. Here, the columns describe the information, while each row represents an individual customer record. Before creating charts, data scientists always spend some time understanding the dataset. This process is called exploratory data analysis, or simply EDA. One of the first functions we use is head, which displays the first few rows of the dataset. This becomes extremely useful when you're working with thousands of records because it lets you quickly preview your data. Next, we use info. This function tells us how many rows and columns the dataset contains, whether there are any missing values, and what type of data each column stores. In our example, we have 5 customer records, 3 columns, and no missing values. Now let's generate some statistics using describe. This function automatically calculates useful information like the average, minimum, maximum, and total number of records. From our output, we can see that the average customer spending is 1,660, the lowest purchase is 700, and the highest purchase is 3,000. These numbers already give us a quick overview of customer spending without doing any manual calculations. Suppose Matthew now wants to identify premium customers. Instead of checking every row manually, we can filter the dataset. We'll display only those customers whose purchase amount is greater than 2,000. The result shows that Sarah and David are high-value customers. Filtering data like this is extremely common in real business scenarios, whether it's identifying VIP customers, expensive products, or top-performing employees. Now, let's make the data easier to understand using charts. Our first chart is a bar chart. A bar chart compares values side by side. When we plot customer names against their purchase amounts, it's immediately obvious that David spent the most, while Ali spent the least. This comparison is much easier than reading numbers from a table. Next, we have the line chart. Unlike a bar chart, a line chart is used to show changes over time. For example, if we plot monthly sales from January to April, we can quickly see whether sales are increasing or decreasing. In our example, sales increase overall, with a slight drop in March before reaching the highest point in April. That's why line charts are commonly used for tracking business growth. Another useful chart is the histogram. A histogram shows how data is distributed. Instead of comparing individual values, it tells us where most of the data is concentrated. In our customer dataset, the histogram shows that most purchase amounts are below $2,500, while only one customer spent close to $3,000. This helps businesses understand customer behavior at a glance. Now let's look at Seaborn, a visualization library built on top of Matplotlib. Seaborn creates cleaner and more attractive charts with very little effort. One example is the count plot, which counts how many records belong to each category. Since all our customers are from Dubai, the graph shows a single category with 5 customers. Another useful visualization is the box plot. A box plot helps us understand the spread of data and identify unusual values, also known as outliers. Businesses often use box plots to detect abnormal transactions or unexpected customer behavior. Creating charts is important, but the real goal is to extract insights. For example, saying, "The average purchase amount is $1,660 is simply reporting a number. A better insight would be, most customers spend less than $2,000, while a small group of premium customers contributes significantly to the business revenue. This kind of explanation helps business owners make better decisions. This is called data storytelling. Good data scientists don't just create charts. They explain what the data means, why it matters, and what action should be taken. Finally, we'll combine everything we've learned in a small mini project. We'll create a dataset, generate summary statistics, identify high-value customers, and visualize customer purchases using a bar chart. This follows the same workflow you'll use in many real-world data science projects. Let's quickly recap today's lesson. You learned what exploratory data analysis is, how to understand a dataset, generate statistical summaries, filter important information, create different types of charts, and, most importantly, turn data into meaningful business insights. Before moving to the next lesson, try creating your own dataset of student marks. Find the average, highest, and lowest marks. Create a bar chart, line graph, and histogram, and write 3 insights based on your analysis. The more you practice, the better you'll become at understanding data. Thank you for watching, and it's quiz time now.